So, as we discussed, like today's topic is about kube scheduler. So, scheduler in the sense what it does exactly by default behavior and how we can control or how we can manage our applications to be launched on a specific node. Okay. So, wherever you try to deploy your Kubernetes, whether it is Azure or OpenShift or AWS or GCP or your on-premises Kubernetes, Podman, Rancher, anything. Okay, so this is really important for us to control our applications to launch on a specific node. Why we need this particular control? Because Kube Scheduler doesn't care about what is your application and what is the node specifications, right? It will try to schedule if that node is having some free enough resources, automatically scheduler will go and launch that particular applications on it. But still I want to control it because I have specific applications where it should run only on specific nodes. Why? Because they are having some high-end resources like GPU, high-end CPUs, and then we have this networking, high bandwidth networking, and then we have more amount of RAM in that particular system, and we are using SSD hard disk and all. So I need some particular specific applications to launch only on that particular nodes. Maybe you'll have some couple of nodes or maybe a single node, whatever it is, but I need to control my launching an application on a specific node. By default Kubernetes scheduler will do it, but it will not guarantee that it will do on the same node. But I need to instruct my Kubernetes scheduler saying that please go and launch this particular pod on that particular node. If that is not available, give me a failure. Okay, so that is how we are trying to control this particular application scheduling. Okay, so scheduler watches for newly created pods that have no nodes assigned. First, what it will see when we are trying to create a new pod in the sense pod may be created through standalone or through workloads. Anyway, ultimately the pods will get created to launch your application. Now every pod like for which you are trying to create for the first time, it will not be assigned to any node, right? For every pod that is scheduled discovers, the scheduler becomes responsible of finding the best node for the pod to run on. So what scheduler will do, due to based on it algorithm, it will try to calculate and it will let pod decide, like it will decide which pod should run on which particular worker. Okay, once a decision has been made, it will go and it will place that particular pod on that particular respective node. Okay, if you want to understand why pods are placed on a particular node, if you are planning to implement a custom scheduler yourself, like if you want to build your own scheduler also, we can do it. Okay, but right now it is not our concept right now, so we are trying to understand how to control this particular scheduler. Okay, so in a cluster, nodes that meet the scheduler requirements of the pod is called as feasible nodes. Okay, if none of the pod nodes are suitable, the pod remains unscheduled until the schedule is available to place it. Okay, so normal feasible nodes in the sense what any pod can run on any like it will accept. Okay, any pod will get accepted on that particular node and it will try to run it. It doesn't have any specifications that only this particular node's pod should run on my node and all. Okay, so that is fine. But when you have some particular concept called factors that needs to take into account for scheduling decision into individual and collective resource requirements. Okay, so when you are trying to schedule some particular pod on a specific node, you have to take into consideration like already how many pods you are running. You know, right? Before you are deploying your applications, you know that okay, I will try to launch only these many nodes on this particular these very applications only on this particular node. Okay, so once you have these calculations and all, then you have to take a right decision in order to launch application only on that particular specific node. Okay, there are many ways to schedule it. Okay, so there are totally many ways to schedule that particular pods. So let me note it down here. Okay, so what are the things we have? Let me try to show you. Scheduling types. Okay, the first and foremost, the basic one is nothing but node name. Okay, so node name. That is the first one, which is a basic one. It has so many disadvantages. We'll talk about that later. And then we have node selector. Okay, so then we have nodeSelector. Okay, and after that we have nodeAffinity, and then we have PodAffinity, and then we have PodAntiAffinity. It is part of it actually, but I'm trying to write it as separate. Anti AntiAffinity. Okay, and then we have Taint and Tollerations. Taint and okay, so these are the 6 topics which you have: node name, node selector, node affinity, pod affinity, pod anti-affinity, taints and tolerations. Node doesn't have any anti-affinity. Okay, so right now we don't have anything like anti-affinity in this. So let us try to understand what is this node name. Okay, node name in the sense simple. Let us say for example you will execute kubectl get nodes, right? Let me show you that. Generally we execute kubectl get nodes, right? When you execute this command, you are getting the node name here. So if you want to launch your application based on this particular node name, then we have to use this particular option. Okay, what you are seeing on this first one. So that's fine. Okay, well and good. But the problem is if this node is having some long name or a different name and this name is not constant, this might change when you reboot your system and all, then you cannot control this, right? So it will be really tough for us to make a decision on this particular node name. Okay, why? Because every node will have a unique name. Actually you cannot have a common name. But let's say I'm trying to launch an application on this particular node, for example, and there is another node as well which is optional. If this node is not available, go and launch on another node as well. Okay, because both the nodes are having SSD hard disk, other nodes are having HDD hard disk. Okay, for example, now I need to launch either on these two nodes. I don't want to launch only on a specific node. If this node is already occupied, my scheduler can launch on another SSD storage node as well. But with this node name, you can tell that only on one particular node. You cannot control like multiple nodes in this particular node name. So that will be a challenging when you want to manage your applications on multiple nodes. Okay, if one node is not available, then it should go and launch on another node as well, right? Then I cannot go with this name. Why? Because every node will have a unique name. So how I can control it? It is not possible, right? So first of all, for time being, let us understand what is this node name. Okay, so how will you write it? So let me create a directory called scheduler. Okay, then let me go to there and let me try to create some sample application. Okay, so I'll take a simple example. In scheduling itself we have something like node selectors. You can see node selector node name. Okay, so I will take this example. Here I have written the statements as well. Okay, so now node name dot java. Now if you see, launch the pod on a specific node using node name parameter. That is what I have written. Where I have written this? Here under the spec of your pod. Schedule pod to a specific node. Okay, so always it is image pull policy always. Okay, then let's save this and see. I don't have this particular node right now, right? Worker node 1. Okay, so see what will happen. So kubectl create -f. Okay, it's saying that it is created successfully, but let's check the status. You can see it is in pending state. Okay, I don't know the reason what went wrong, but here you can see the node name is worker node 1. Okay, but what is your node name? Get nodes. You can see that your node name is compute plane 1, but here I see a name called worker node 1 which is not available at all. There itself I can suspect that okay, there is some issue in specifying the node name. But let's try to see the description of this particular pod and see what it shows in the event logs. Okay, so kubectl describe pod and the pod name is nginx. Okay, you can see there nothing is being shown. Okay, nothing. Okay, so here we can see this, there is an issue with the node name itself. Now if I try to modify this with the proper name, that is nothing but compute plane 1, right? You can understand this if I want to have some multiple choices, either this node or that node. This is not possible with node name. Okay, so that is what we have to understand. kubectl apply -f. Okay, you can see I did apply. Okay, so let's see this describe. You can see now it is scheduled. Okay, now if you look at your status of your pod, you can see now it's running. Okay, why? Because this particular node you have it. Okay, so this is how it is. The benefit, the loss of this particular concept is nothing but there is an upgrade is going on. I need to evacuate all the pods which are running on this particular node. Evacuate in the sense I want to shift the pods when I'm trying to do some OS upgrade or patchwork on the operating system. I want to shift all the pods which are running on this particular node to another node. Okay, so while doing that particular command, this particular pod will not get scheduled. It will be in pending state. It will get removed from that particular node, but it will not go and launch on any other node. Why? Because as per the concept you have told that you should run this particular pod only on that particular node. Okay, so when you don't have that particular node available for scheduling, obviously it will fail. Okay, so those are the things which we have to remember when we are working with node name. So to overcome this particular situations, when you have multiple nodes of choice to launch your applications, then we can use node name, which means that, sorry, node selector. So node selector in the sense I have, let's say this is my control plane node, and let's say I have other two nodes, let's say three nodes for example. I have these many nodes. Okay, now this node is having SSD hard disk, for example. This is having SSD and this is having SSD. Okay, now I want to launch an application, for example. I want to launch application. Okay, now when you're trying to launch an application on this particular nodes, if I use a node name, either it will launch on this or that, some particular node, right? Let's say this is worker, for example, worker node 1. Okay, this is worker node 2. Okay, and this is worker node 3. Okay, and this is worker node 4. Okay, now we have these many worker nodes. Now if I tell to my scheduler that I'm using a concept called node name and try to launch only on this particular node, it will launch only on this node. If some maintenance work is going on this particular node, we will try to disable the scheduling and we will evacuate the pods from this node to any other node. Automatically Kubernetes will take care of it. If you try to evacuate from here, means we are trying to remove the pods on this particular node and we are trying to schedule on any other node. Okay, so Kubernetes will take care of it. But here when you are evacuating a specific pod which is expected to launch only on this particular node, that will be in pending state. So if that particular application is down, obviously your client or any other application which is utilizing this application will get interrupted. Okay, so to avoid this particular problem, we are using a concept called node selector. So node selector in the sense what you will do right now, you will add some label to this particular two nodes. Okay, some common label saying that env is equal to ssd disk. Okay, so here also I will be adding something like env is equal to ssd hyphen disk. Now what will happen, I will use this particular label. Okay, so when I use this label and now I have, which node is having this two label actually two nodes. These two nodes are having my label right now. So my scheduler will pick either this particular node to launch or either this particular node to launch. Okay, so the benefit is either it will choose this particular node or it will choose this particular node to launch my application. Okay, so for that we use a node selector. Now I have a choice, like either I can launch an application on this particular node, or if this node is already occupied with enough amount of resources, then it will go to the next node which is having the same label and it will launch your application. Okay, so let us try to see that. So what you have to do, either you can use the existing labels. Okay, every node have some predefined variables actually when you form your Kubernetes cluster with kubectl command. So when if you want to see that, kubectl get nodes, in order to see the labels of any object, show hyphen labels. I'm not talking only about nodes and all, even for pods, like any other component. You can see compute plane is having only these many labels, whereas your control plane is having so many labels at all. Okay, so many labels actually. Okay, so this is what you have to understand. Okay, now here the concept is either you can use this one or you can add some new labels to your nodes. Now let me add. So I will add only this particular label to this node. Tomorrow what I will do, I will integrate another node to this particular cluster. Okay, so then I will show you in more concepts of this. Okay, we already have a good amount of video which talks about more of node affinity, pod affinity, anti affinity, taints and tolerations. Okay, I'll be sharing that particular video as well. Okay, now coming to the point, what is this node selector? So node selector is something where you have to add some label to your nodes on which you are expecting this particular application to run. Okay, so always it is better to have more than one node available for us to schedule. Okay, don't try to make it to a pod to be scheduled only on a specific node. Okay, so that is not a right choice or a right way to do in production as well. Okay, so we have to put one choice. Okay, so not only in one node, we have to have another node as available to launch this particular application if it is really needed when upgrade process, or if your pod has been crashed, or if you are doing some patchwork on your operating system or something on that node. For everything you have to do have a proper solution for it. Okay, always think beyond the basics. Okay, now this node is having labels. Okay, that's fine. Let me add a new label to this particular compute node and let me try to
Uh,
launch. Okay.
Sudeep,
Yep.
I have a question here.
Yep.
Okay, so if I have a big cluster and thousands of pods are running, and I want to filter only those pods which those are having node name is equal to this, whatever the node name.
You can
So
add a
how I can
filters. You can add a filter. Okay, so
Mhm.
when you're executing kubectl get pods and all, right, there are so many options to
Mhm.
add a filter actually. So you can add a custom column, we can customize your output, you can filter only a specific parameters and all. There are so many options actually. If you get
Yeah.
kubectl get pods hyphen f and help, right, you have these options. Let me show you that field selector. Okay, so this is where you can use. Okay, if you want to customize your output, if you want to filter only a specific, let's say my requirement is I want to print all the pods which are running on a specific node. Okay, I don't bother about the labels and all. I want to filter all the pods which are running on a specific node, then this particular
Mhm.
filter will come into picture. Okay, field selector actually. Okay, so in this way we can manage our output as well. The default behavior is it will show whatever the output is recommended, that will be shown by default. But still, if you want to customize your output in printing the values and all, then this is where it will help you when you're doing some CI/CD automations and all. Okay,
Mhm. Okay.
so now let's try to add a label to my nodes. Okay, so what I will add is nothing but kubectl. What is the command? Label. I'm trying to add a label to whom? It is to node. If you want to add a label for any other objects, you can see this help. Sorry, you can see. You can add label to anything. Okay, for pods, okay, deployment, daemon sets, everything you can add a label. Okay, so right now I'm adding label only to my pods, sorry, to the nodes actually. Okay, so kubectl label node, to which node it is, compute plane 1. This should be something like a prerequisite. Prerequisite is when you are launching your Kubernetes cluster itself, try to add all the prerequisites whatever it is needed before installing your applications on that particular cluster. Okay, so that is a right way to do. So kubectl label node and node name, and then the label is env hyphen ssd hyphen disk equal to env equal to this. Okay, done. The label has been added. So let me show you. You can see this actually. Env is equal to ssd hyphen disk. Okay, now how will you use this? That's a major question, right? So let's try to add node selector dot yaml. Now node selector dot yaml. So here, instead of this particular concept, now we will come up with a concept called node selector. Okay, so node selector, and then you need to write your key value pairs. Okay, so the key value pairs is env colon, and then what is the value? ssd hyphen disk. Okay, now let's see. I'll give some wrong name. See there, again it's the same failure. It will be in pending state. Let's see. Let me delete the old pod which is existing already. Now let me try to create it. Okay, so now if you look at the status of the pod, now we can see in pending state. Okay, so let us try to give a describe pod. Okay, you can see there it is clearly showing you in the event logs failed scheduling. Why it got failed? Default scheduler is saying that you have two nodes are available. You have two nodes are in available status. One node did not match the pod, nodeAffinity and selector. One node has tainted. Tainted in the sense your master node is tainted to not to launch any pods. But rest of the node, one node is having does not match the pod node affinities or selector. That's the reason why it is not able to launch. Either the pod affinity or the pod selector is not matching to the label, any one of the label on the nodes. So that's the reason it is not able to schedule the pod. Okay, so that is what it is clearly stating you that. Then you will cross verify what you have written and what node is having, and then you will try to do some modification or correction. So now what I need to do now, node selector, I need to do my correction on the selector which I have written, right? Now in order to apply this, kubectl so this is not okay, let me check. It is showing you some warning, forbidden. Okay, so it is not allowed, right? So what I will do right now, force replace. Okay, it will delete and it will replace. So now if I go to the pod, now you can see it's running. Okay, if you try to give a describe of this particular pod, you can see it got scheduled to the node. Okay, and we can see in this particular section as well, we have some particular concept which is shown here. It is called as node selector. Okay, maybe you have to give some describe. Maybe it is not showing you here. Yeah, here it is. Okay, node selector, and you can see this particular key value. Okay, so in this way still we can modify. So there is some disadvantage in the node name, so that's the reason we are using this particular concept in order to have some leverage of launching the application on multiple nodes. either of the nodes. Okay, because all the time you cannot guarantee that the node will be available, right? It might get crashed or something. So you have to be in a situation where you have to have another node to get accepted to launch this particular application. Okay, so that's where first solution is not feasible for us, and then we are going to the second solution as well. Okay, so here also there are some particular concepts which is like had some disadvantages and all. Okay, so to overcome that particular disadvantages, we have a concept called node affinity. Okay, so what is this node affinity and all? You can search for your official documentation itself. Assigning pod to nodes. Okay, you can see node selector and then add node selector field to your pod configuration. What we have done, you can see it, and then interable built-in node labels. That's okay, fine. So we already seen like what are the predefined node labels which we have, and then we have affinity and anti-affinity concept. Affinity in the sense try to launch on the same node. Okay, anti-affinity is not to launch on the same node. If something is running on that particular node, try to not to launch on the same node. My application, don't launch my application on the same node. That is called as anti-affinity. Affinity in the sense wherever some application is running, launch my application on the also on the same node. Okay, so that is called as affinity and anti-affinity. Okay, so there are some particular rules which you can add. One is like soft rule and hard rule. Soft rule in the sense, even though if it is not available, please go and launch on any node. But my first priority is to launch on this particular node. If that node labels are also not matching, please go and launch on any other node. That is called as soft rule. Hard rule in the sense, if that particular rules are not matching, like if that label is not matching to anything, then try to fail it. Okay, so that is called as hard rule. So this is how we follow in affinity and anti-affinity, soft and hard rules. Okay, so let's see node affinity. Node affinity is conceptually similar to the node selector. Yes, it is true actually. Why? Because node selector in the sense you will add some label, and with that label you will define your pod YAML file to launch this particular pod only on that particular node. That's well and good. It allows you to constrain which nodes your pods is eligible to be scheduled on based on labels on the on the node, right? So that is what your node selector is doing. What it will do, which node is having that particular labels, and what you have defined in your YAML file, and if that is matching, it will go and launch your application on that particular node. So currently there are two types of node affinities actually, which I have already told. One is required during scheduling, ignored during execution. Okay, so one is required during scheduling, ignore during execution. So let us divide this into two parts. Require during scheduling in the sense while the pod is getting created, that is called as required during scheduling. Okay, when your application or object is getting created, that is called as required during scheduling. Ignore during execution in the sense after the pod has been scheduled on that particular node, if label has been removed, please ignore, don't try to do anything. Okay, only when you're trying to launch it, consider this particular labels. If once a pod is already launched on that particular node, if you remove your label on that particular node, nothing should happen to your pod. Okay, for example, in label node selector also, let me try to remove the label. Okay, so kubectl label. Okay, node compute node 1. Okay, how to remove a label? Env hyphen compute, compute plane. Now you can see the label has been removed actually. How will you see it? Let me show the labels. Show labels on the node. You can see now. Can you see any label related to one which we have added earlier? No, to my compute node. That's how you remove. Remove in the sense simple. You have to give your key name and then you need to give hyphen. So automatically it will remove that particular entry. Okay. Now what will happen to your pods? Your pod is still running. Nothing happened to your pod. Okay, you can see this. Your pod is still running and nothing happened to this particular pod right now. This is called as required during scheduling and ignored during execution. Okay, so required in the sense mandatorily your labels has to match. If not, it will fail. That is called as required. Okay, there is another parameter called preferred during scheduling, ignored during execution. Ignored during execution is same. Okay, once it is launched, even though if you remove your labels, nothing should happen. Okay, Kubernetes is trying to implement the new options as well. Required during scheduling, required during execution, preferred during scheduling, preferred during execution. So those are the two options which are also Kubernetes is trying to add. It is not yet implemented in the latest version as well, but let's see, maybe in future you might get it. Okay, so now let's try to understand preferred during scheduling in the sense, preferred in the sense it will have high priority that you need to have the label. Okay, if a label is also not there, please go and launch somewhere. Okay, so that is what is preferred, which is called as soft, and this is called as hard, like execution. Okay, so hard rule and soft rule. Okay, well, the later specific preferences, okay, node selectors, and if the label of the node changed at runtime such that the affinity rule on the pod are no longer met, the pod continues to run on the node. That is the meaning of ignore during execution. So ignore during execution in the sense if the labels have been removed or changed. Okay, so what will happen, affinity will not take care of the pod even though if the labels have been not removed actually. So the pod will keep on running on that particular node until unless something happens. Okay, so see, in the future we plan to offer required during scheduling, required during execution, and which will be able to do identical to required during scheduling, ignored during execution. So right now they have not implemented, but they are planning to implement this. Okay, so this as an example only runs the pod on the nodes with Intel CPU and the example like this. Okay, so what is the benefit now I get apart from node selector? I already have a node selector. Why can't I use that? Why I have to go for that? Actually, in the node selector, if the label is not matching, it will fail. That is the first thing. Whereas in the node affinity, even though if the label is not matching, but that is the high priority. Priority in the sense that is my priority. Please try to check if the node is having this label, go and launch this application on that particular node. If it is not having, okay, please take your own decision and try to launch your application on any node. That is called as preferred during scheduling, ignored during execution. Required in the sense mandatory. So you have some options, more logical expressions you are trying to add in scheduling your applications. So that is not possible in node selector, right? So if you want more logic to be added to your application running on a specific node, then we need to go for node affinity. Okay, so you are writing affinity and node affinity, and then you are writing required during scheduling, ignored during execution, or you can write preferred during scheduling or ignored during execution. Now you can see here he is trying to search for what is another benefit you get is nothing but match expressions, which means that one key can have multiple values, right? If either of the values matching, I can take consideration that this label is also accepted. Okay, so I can add multiple labels and I can say if this label or that label is available, try to launch your application on that particular node. Okay, so this match expressions is not available in your node selector. You cannot write anything else. Okay, apart from defining the hard-coded labels. Okay, so this is how it is more useful in your production servers when you're handling your applications to run on specific nodes in a proper way. Okay, so let us take an example of it. Node doesn't have any
Uh,
anti-affinity.
Sudhir,
Yeah,
in this example, I have a question.
yeah, this one. Okay,
Which Yeah. So here they are using both required during scheduling and preferred during scheduling. What does that means here?
sorry, you were saying something.
Uh, uh, yeah, I'm saying that under the node affinity, they
Huh?
are using both keys, like
They are
required during
using.
scheduling and
Your voice is
both
breaking actually.
keys. Now it's clear.
Yeah, better.
Okay, so I'm saying under the nodeAffinity, they are using both keys, required during scheduling and preferred during scheduling. So
Yes.
what does mean here?
See, they have given in one particular location, but it is recommended to use only any one of them. Okay. As I told you, required during scheduling in the sense it is hard code rule. Hard code rule in the sense this label, either of these two labels should be there. If it is not there, what will happen? Your pod will be in pending state. Okay. Whereas preferred during scheduling, ignored during execution in the sense it will try to check for this particular label of any one of the node. If that is not available, your kube scheduler will take a decision of launching the application on any node. Okay,
Yeah,
this is
I
called as
understand.
soft
I
rule.
understand individually. Yeah, I
Okay,
understand this concept individually, but I'm just a
see,
little
they
bit
have written
confused
only for
because
this
they are
example, but we should not write this combination. Okay, it is only for the example. Okay,
okay.
yeah. Now it is checking for three labels actually. If you try to write this combination, right, either this label or this label or this label. If any one of the label is not matching, you are giving some combination. Here it is telling like reject, and here it is telling you that okay, which one will get prioritized. So that decision cannot be made, right? So that's the reason it is always recommended to write only one of them, not both of them at a time. Okay, that's how it is. So yeah, now what I need to do is nothing but node affinity. Nodes doesn't have anything like anti-affinity. Okay, so that is not possible in nodes. Okay, so in the pod we have something like affinity and anti-affinity. Okay, so what does it mean? Pod affinity in the sense, if there is one application running, application called A, it is running on specific node. Okay, I want to launch my application B on the node, sorry, on the node where this particular pod A is running. Okay, if you want that particular feature, then you have to go for pod affinity. Wherever a pod is running, for example, I have a log monitoring tools. Okay, wherever my log monitoring tools are running, there I need to run some application to fetch some data. Okay, so if you want that particular feature, then you have to use pod affinity. Okay, it will rely on a specific pod. It is not relying on any labels on the node or something. Wherever this particular pod is running, I will also run my pod on the same node. That is called as affinity. Anti-affinity in the sense, wherever this particular pod is running, I will ensure that my pod is not running on the same node. Okay, so that is called as anti-affinity. Okay, so that is a basic way of understanding this particular concept. It is huge, so I will explain it later, okay, one by one when we see the examples. Okay, so let us go to the example called node affinity. Okay, so in the node affinity you can take this example which talks about it. Okay, so this we already seen, so no need to discuss about this. So now we have something like node affinity. Okay, so let's take this. I'll take this example. Let me remove all of them. Now, okay, it is a wrong name. Okay, any of the node is not having this label. Okay, let's see. So keep it here. Just I want to show the failure, then I just want to create a proper one. Okay, so that we'll get some idea. Okay, it's saying created, but let's see whether it is really scheduled or not. So kubectl get pod hyphen oy pod get. You can say it is pending state. So obviously you will check the like description, right? kubectl describe pod and the pod name. Okay, you can see here it is the same functionality of what it is trying to say. Pod node affinity or a selector is not matching, okay, to the labels what node is having. So that's the reason it got failed. So simple statement and a valid failure right now. So what I will do, what is the labels that I have defined in my YAML file? Let's see. I will try to add the same label, nodeAffinity. So this is the label which I'm trying to prefer. Disk type, SSD server or HDD server. Okay, I will add only one label and see whether this particular pod scheduler will try to detect any one of them or both should be matched. Okay, will it check that both the labels are there or only one label is enough for us, or condition or and condition. Okay, so let's see. So kubectl label node compute plane 1. Okay, and then label is disk type is equal to SSD hyphen server or something like HDD hyphen server. Let me add HDD. Okay, this is done. Disk type. So now the label has been added, right? If you see, look at your notes, show labels. You can see now the label has been added. Where it is, you can see here. Okay, done. So what happened to your pod? Let's see. So you can see now it's running. So it got detected in the next restart. After a certain interval, it will recheck once again. So in the recheck, it says that, okay, one of the node is having this label, what I'm expecting for, and it got launched. So either of the label, either I'm looking for disk type SSD or I'm looking for disk type HDD to launch this particular application. Okay, so this is called as nodeAffinity. So and then you are trying to add this logic called match expression, saying that either this label or that label. If any one of the label is not available, it will go into a pending state. Okay, so that is all about your nodeAffinity. AntiAffinity, PodAffinity, AntiAffinity, let me share the video. It clearly explains with lot of examples. Actually, I took so much time to explain it actually. Okay, so you can watch that video. So both the videos I will share it today. So watch that video thoroughly and come up with the questions or anything. Why? Because in the examination they will ask you only to add something logic called nodeSelector or a node name. You will not fall into a nodeAffinity or PodAffinity and AntiAffinity. They will not ask you from here. Or they might be asking from Taint and Tolerations. Okay, there is one more concept called Taint and Toleration. So either you get a question from node name, nodeSelector or Taint and Tolerations. You don't get anything right now related to nodeAffinity, PodAffinity and AntiAffinity. Okay, so that you can take care of it. So in the next video, you will be watching about that. What is this PodAffinity? What is this PodAntiAffinity? What is this taint? And what is a toleration? Okay.